When we change the interpreter for lambdas, lambdas don't have immediate calls to interp. We just create a close v, and we'll continue to do that just as before. Instead of returning the close v, the rule though is that we always continue with our to-do list. So we've just changed the case for lambda by wrapping a continue k around it. Application does have nested calls to interp. Remember, when we have an application expression, we have to evaluate the function expression and then the argument expression. So here we see our updated app case, which starts evaluating this function expression, and what it remembers is that after we're done with that, we need to start evaluating the argument expression with the same environment. When we do continue, we will start interpreting that argument expression in its environment. We will remember the v here, which will be the result of interpreting the function expression. So that should be some function. We'll remember that we need to actually apply that function with doAppK. So eventually, when arg a turns into a value v, then we'll be here and continue at the doApp case, where vf was the value of the function that we recorded. We make sure that in fact it is a function value, that it's a closure, and then we start interpreting the body in an extended environment as we always have. The only thing that changes compared to that old interpret the body is we add a continuation record. And that continuation record is the next k that we originally saved way up here. That was, where does the value go when you get a value back from calling a function? So that's the same continuation that we end up passing to interp. Let's try stepping through a use of this part of the interpreter. I need to make the code smaller, and I'll need an abbreviation. Let's let E1 be the environment that binds f to the identity function, a closure that has an argument x, returns x, and starts with the empty environment, and we'll extend the empty environment with that. So with that abbreviation, let's try interpreting the application of f to the number 1. F is going to be bound in this environment E1, and then we don't have anything to do after we apply the function f. That interp call will hit the app case of our interpreter, so we'll start evaluating the function expression, which is this f expression. So we'll interp f in the current environment still, and we construct an app arg k, keeping the argument expression with its environment. So that expression is E1, is rather num E1, and the environment is E1, and the rest of the continuation k was that done continuation. So we're interpreting the expression f. The interp will go to the IDE case, which does a lookup in this environment. It'll find f bound to this closure. So that is a value that we'll be able to continue with immediately, that same closure. And our continuation is the app arg k continuation. So that will take us to this case of continue, which starts interpreting the argument expression. That is, the argument expression is num E1 in E1, the environment. And our continuation becomes a doAppK, where we remember the value v. The value v was this closure, so that closure goes into the doAppK, extending the empty, the done continuation. So we start interpreting the num E1. That gives us a num v1 immediately, and we continue with the current continuation. That's a doAppK continuation, so we'll be in this case. We will check the vf that is in the application record, doAppK record, and we see that it is a closure. So we'll get here to this interp of the body of the closure. That is IDE of x, and we'll take the environment in that closure, this empty environment, extend it with the binding of n to v. N comes from the closure, so that's the x. V is what was passed in the continue call, so that's a 1. So that's why we bind x to num v1, and then we have next k, that's the rest of the continuation in the doAppK. So that's dumb k here. So you can see that we're down to the point of interpreting the expression x in an environment that binds x to 1, and once we do that, we'll be all done. In fact, the IDE case of interp will just do a lookup to find the num v1, continue with done k, and we'll get num v1 as the result of this program.